the time slot. And yeah, like you said, this is a very appropriate presentation for today. I think it really applies, and hopefully what we talk about today with the blizzard warning decision process, forecasters can take back to their offices and at least start a discussion. I think the main point for this presentation is to really start that discussion to try to get us toward more consistent philosophy when it comes to what is a blizzard. So the main point of this presentation is kind of to answer that question, what is a blizzard, and to show you maybe it's not quite as simple as just looking at the criteria that's in the directive. So I've given this presentation a few times already, nothing really in the past year. A couple years ago, I gave this presentation at the St. Cloud Weather Conference, which consists of a few Northern Plains offices. And I also gave it to obviously our office and then a couple other Northern Plains offices during their winter weather workshops last year. So like I said, this presentation isn't really meant to provide an answer, but really to get the discussion going within your forecast offices. I have added some bonus material from the original presentation that I gave last year and a couple years ago, just talking about some messaging tools we have and some things to consider when trying to message blowing snow. So like I said, kind of the overview objective of this presentation is to get us to start thinking about the blizzard warning decision process, and that it's not quite as easy or simple as just following the criteria. And I think, that oftentimes when we're trying to make headline decisions, and in this case, trying to decide whether or not we should issue a winter weather advisory for blowing snow, or whether or not we should issue a blizzard warning, or whether or not we should maybe just issue a high wind warning because we're not, maybe the snow isn't blowable out there. So meteorology often is not the issue. I think we're pretty good at the meteorology, although that can be complicated as well. But oftentimes it's those philosophy differences from forecaster to forecaster that make the decision process more complicated. There's lots of factors to consider. I think there's, especially in blowing snow events, there's such a large spectrum of impacts from event to event, and we need to keep that in mind. And then especially those marginal or lower impact type blizzard events, especially the ones that occur without falling snow, the ground blizzards, or as the Canadians call them, the blue sky blizzards, those are sometimes the trickiest when we're trying to make that decision of whether or not we should issue the blizzard warning. And this isn't just before the event starts. It can also often be a difficult decision to make as conditions are ongoing, just because of the coverage of blowing snow or whatnot. So hopefully I've kind of convinced you that it's complicated, and oftentimes it's not the meteorology. And hopefully that we're all also on the same page that, consistency is important, because I think if you're consistent from event to event, you don't have one forecaster issuing blizzard warnings when there's just isolated whiteout conditions. Well, another forecaster waits until there's widespread whiteout conditions. If you have that inconsistency from event to event, I believe that your blizzard warning effectiveness is not going to be as great as it could be if you were consistent. So we're going to try to answer that question, what is a blizzard? So this is obviously this is the criteria that's in the directives. And I think the criteria in the directive is very important to follow for what is a blizzard warning. The criteria is fairly straightforward, but once you start throwing impacts into the equation, I think the simplicity vanishes. And as we talk about some of the factors moving forward in this presentation, hopefully I kind of try to explain that statement a little bit. So, when you're thinking about criteria, sometimes that can be simple, but then you start throwing impacts into it and it can become a little bit more complicated. So one thing that I've noticed in the 18 years that I've been working at the Grand Forks office is that there are different impact levels from one blowing snow event to another blowing snow event. And I think the two main factors that influence those impacts are duration and coverage. So the greater the coverage, the greater the impact from blowing snow. The longer that the blowing snow events last, that will also increase the impacts from blowing snow. And I'll try to explain that a little bit further. So let's just kind of talk about coverage for a second. And imagine you are driving down the road, and you're in a car driving down the road, and you're in and out of whiteout conditions. So you're driving down the road, you can't see anything, but maybe a minute later, conditions or visibilities improve and you can see a half mile or a mile down the road. Your chances of becoming disorientated and maybe driving in the ditch are much less if there's this opportunity to get out of those whiteout conditions and into conditions where you can see. And let's also then talk about duration, right? So what about the duration of blowing snow event? So let's say that you're stranded in a vehicle during a blizzard. Let's say that for whatever reason you drove into the ditch, you can't get out. If that duration of that blizzard is only 2 or 3 or 4 hours, or that you're stuck in that car, the chances of you getting rescued or the chances of you being able to get out of that situation are much better than if you're stuck there for 12, 14, 24 hours. That then is becoming very much life-threatening if you're stuck for a longer duration. So I think the coverage and the duration of blowing snow, as those two increase, the impact from a blowing snow event also increases. So another thing that I wanted to mention is that, a blizzard is and should be our flagship winter headline. Much like the tornado warning in the summer, I think the blizzard warning has to be thought about as our flagship winter weather headline. So when we issue a blizzard warning, we, I believe, have to be thinking about what should be the resultant impacts. Should all roads be closed? When we issue a blizzard warning, are we intending for schools to close if schools are in session? And kind of that first bullet there, I truly believe that since that blizzard warning is our flagship winter product, that when we issue the blizzard warning, we are basically intending to shut down the world. We're telling people that if they drive on the roads, that their life is in danger. We're basically wanting to close businesses. We're wanting to shut down the world when we issue that blizzard warning. And I think that's what we really need to have in the back of our heads when we are making that blizzard warning decision, whether or not to issue the blizzard warning or not. So there's other things to consider, right? What about drifting? Maybe there's one, say, blue sky or ground blizzard event where conditions are very bad for that duration, but maybe the blowing snow, maybe the coverage isn't maybe just 50%. Maybe you're in and out of whiteout conditions, but the drifting is so bad, your ditches are full and the roads are just getting shut down because people just can't travel on the roads. Maybe that's something to consider. Towns versus sheltered areas is something that we'll go into as well. Is there ever a true blizzard in town? Maybe, maybe not. But I think, it depends on the rate of the falling snow really to get, those whiteout conditions in sheltered areas. And sheltered areas aren't just cities or towns. Sheltered areas can also be, forested areas as well, or, anything that basically shelters an area and limits the blowing snow potential in that area. So those are other things to consider. And like I said, when we, does a blizzard warning, should it equal people getting stuck or stranded if they attempt to travel? Should all roads be closed? What about blizzard warnings with weaker winds? We often have, where we don't have sustained winds, maybe less than 35 miles per hour, but we are getting those frequent gusts. And at colder temperatures, the snow blows around a little bit easier, so it doesn't require as strong of winds to reduce that visibility down to a quarter mile or less. So we have to try to keep that in mind as well. And that last bullet, there are whiteout conditions for 3+ hours, the only thing to consider for blizzard warnings. And that's where we start thinking about impacts. What if you have 2 hours of whiteout conditions, but they're occurring during a busy morning commute? Is that enough to issue a shorter term type blizzard warning? Now, all questions that I don't have the answers to, but I think all questions that we need to think about it and consider. So when we a few years ago tried to answer this question, what is a blizzard, we came up with an approach to try to bring consistency to the answer. And this kind of came about after the 2013-2014 winter weather season, where I believe we issued 9 or 10 blizzard warnings. And some of the blizzard warnings turned out to be very serious situations, but other blizzard warnings that we issued that winter season ended up being kind of marginal blizzard warnings, where people were still out traveling, and the feedback we received was, well, that really wasn't that bad of a situation. You're kind of watering down the blizzard warning by issuing that product for these situations. And this feedback that we got after that winter season came from a winter IWT, basically, that we started because of that winter season. And this is kind of the feedback that we got. So we really wanted to then look further into trying to bring some consistency to answer the question, what is a blizzard? So in order to do that, we kind of came up with this 3-step process. The first step was we wanted to try to determine the different impact levels from past blowing snow events. And from those past blowing snow events, we then attempted to decide if we really wanted to shut down the world for that particular impact level from that particular blowing snow event. And then the third step in this process will be trying to find guidance to help us be more consistent from event to event for decision making and for messaging. So Jeff Mikowski, who was at our office until a few years ago, he is now a forecaster at the La Crosse office in Wisconsin. But he kind of led the way, and in 2016 published a Central Region Tech Attachment, basically looking at blowing snow events just within our forecast area. And these blowing snow events were 2000. All the blowing snow events are basically all the blizzard events that we have from 2006 to 2014. And the way that we tried to determine the impact level from these blizzard warnings that we issued is we looked at all the ASOS and AWOS observations within our forecast area. You can see the image where all these locations were. And we then just attempted to determine the coverage of the blowing snow and then the duration of that coverage within each blizzard warning. So in order to do that, to find the coverage, we basically calculated the percentage of the stations within the blizzard warning that were had visibility less than or equal to a half mile, and then the percentage of stations within each blizzard warning that had visibility less than or equal to a quarter mile. So for example, let's just take Grand Forks County has 2 ASOS sites, the Air Force Base and the airport. So if one of these sites had a visibility of less than a half mile, that would basically say that the coverage was 50%. So 50% of the area had visibility less than half mile. It's not a perfect way to go about it. Obviously, the ASOS, AWOS sites are not perfectly distributed across the forecast area. But if you're trying to determine percent coverage, it's kind of the only way. And I think it at least gives you a reasonable first guess solution, or a reasonable first guess attempt to try to calculate the coverage and duration of those visibility thresholds for the past blizzard events. And there's some other examples there. Just one thing that I wanted to quickly mention is, if a blizzard warning is quarter mile or less visibility, why the heck are we calculating also the half mile visibility threshold? And the reason that we do that, automated sites are typically free of obstructions, but there's often some obstructions in the way, and they may not really be representative of open country. And subjective and analysis and experience has shown that, at least in our neck of the woods, that when the ASOSs or AWOSs indicate a half mile visibility in the daylight hours, that the open areas between these automated sites are often less than a quarter mile. So that is kind of the reason we wanted to use that half mile threshold, because of that past subjective experience. So by doing all that, and you don't have to really look at these tables too in depth, I just kind of wanted to throw a few tables and some results on a slide, just to show you kind of the results that came out of it. But for example, for this first event, January 24th, 2006, there were 13 stations within the area of the blizzard warning. So of those 13 stations, 38% of those stations had a coverage of less than or equal to a half mile. 31% of those stations had coverage less than or equal to a quarter mile. The duration of the 38% of those 13 stations that had the coverage of less than or equal to a half mile, that coverage lasted for an average of 1.37 hours, so just less than an hour and a half. You can see again then the average of all the blizzard events within our forecast area, and then also the chart for the quarter and the half mile visibilities that kind of show the coverage on the x-axis and the duration on the y-axis. And the one thing I wanted to point out, at least with these charts, is, and we'll kind of see this moving forward, is that the impacts from these events, more schools were closed, more roads were getting shut down. The impacts increased as we kind of increased the coverage and duration. So, these events kind of in the top left of these charts had the highest impact. So determining impact levels from past events and trying to then answer the question, do impacts increase with greater duration and coverage? The way we tried to answer that question, or the way that we did answer that question, was pretty subjective, and I'll admit that now. Basically looking at events that at each event, using personal reports, sometimes looking at webcam images and loops, kind of like the one you see on this slide now, using social media posts, and more recently kind of using plow cams and then the ASOS AWOS reports, and looking at how many roads were closed and were schools shut down and that type of thing. I will say that I think as we move forward, especially with maybe machine learning or AI becoming more or better established, that I think we can probably come up with an objective methodology to try to determine the level of impact from a blowing snow event, using different tools or whatever, beyond my knowledge, but I think it is kind of the next step in this process. So we do need a more objective analysis, but from our, what I feel is a pretty well subjective analysis, going from experience and that type of thing, we were able to determine or kind of decided that these past blowing snow events had more or less 4 impact levels from the events that were in our database. And I think the easiest way to explain these impact levels is kind of by describing whiteout conditions. So, as a way to explain each impact level. So for example, a blowing snow event with a low impact level would have sporadic or brief whiteout conditions if a person was just standing in one place. What if a person was moving or driving down the road? A low impact level, that person driving down the road would experience isolated whiteout conditions. So, whiteout conditions maybe 20% of the time, something like that. As the impact level increases, the percent of the time that you are experiencing whiteout conditions or visibility less than or equal to a quarter mile, I think is how we can kind of define whiteout conditions. That period of time you're experiencing whiteout conditions increases. So at a very high impact level, very high blowing snow impact event, if you're stationary, just standing in one place, let's say you're in your house looking out the window, you have constant whiteout conditions. You never see any breaks in the visibility from that blowing snow. If you're driving down the road, the whiteout conditions are widespread, or likely you can say they're constant again. So that's kind of the way that we like to or try to define these impact levels from past blowing snow events. So how does that relate then to, what is a winter weather advisory for blowing snow? What is a blizzard warning? And I think, if you think about it, and you think about driving down the road, and if you don't experience a lot of blowing snow events, this might not make a lot of sense to you. But if you have experienced blowing snow events in the past, if you think about driving down the road and how the blowing snow is impacting you, I think this then kind of starts to make a little bit of sense. So when I had first moved up here, I was probably 4 or 5 years into my experience of real blowing snow events in North Dakota. And I had to take my dog down to Castleton for a vet appointment. And there was a blowing snow event. We ended up having, it was a advisory type event. So, it was sporadic, brief, isolated whiteout conditions, but I was able to make it to Castleton, and I was able to make it, maybe about an hour and a half away, and I was able to make it back home. It got pretty bad for brief periods of time, but I knew that if I just kept driving during these brief whiteout conditions, that I would get out of it very, very quickly. And I had to slow down a little bit, right? So I was advised to slow down. But with that said, I was still able to travel. But I think we can also all agree that, if we're moving and we're experiencing whiteout conditions 70, 80, 90% of the time, or all of the time, that is a more serious situation, and likely then requires a blizzard warning, or requires us to really want to try to shut down the world. I think it's this area in between, what we kind of define as the moderate impact level, where you're experiencing, if you're just standing in one place, where if you're experiencing occasional or periods of whiteout conditions, or if you're driving down the road and you're experiencing scattered blizzard conditions. So let's say you're experiencing whiteout conditions 50, 60% of the time. That is where we have the biggest issues from event to event, trying to be consistent with what is a blizzard. And that, I think, is one of those areas where in the past, especially before we really started talking about this, that we were very inconsistent from event to event. And I think we're starting to learn now how, it probably, you can go either way with this moderate category. But if it's just a ground blizzard event, it's probably more toward the advisory or the lower end of the spectrum. But if you're starting to say, get strong or heavy drifting, where the drifting is shutting down roads and making travel impossible, then maybe that kind of tips the scales more to a blizzard warning. This slide is just kind of a side note that I wanted to throw in, and just to make sure that I mentioned it. But using the thinking up until this point, there is a way, I believe, to determine real-time impacts using visibility observations from our ASOS and AWOS data. We're currently working on developing a real-time situational awareness tool, but just by going through everything that we've gone through, researching conditions and impact levels and such, we've kind of determined that, when the visibility from an ASOS/AWOS station during the daylight hours, is zero, that's usually a very high impact event where your coverage is of whiteout conditions is pretty constant or pretty widespread. And then at least relating it to coverage, as the visibility kind of increases, the impacts lower, or the coverage of the blowing of those whiteout conditions starts to decrease as well. One important thing to keep in mind is during the nighttime hours, or when it's dark outside, the visibility from an ASOS/AWOS station will be slightly higher for the same exact situations, same exact, visibility compared to the daylight hours. It's just the way that the ASOS calculates visibility, and you can see on the chart there on the right. Why is this important? And we've had several instances in the past where, it's 4, 5, 6 in the morning, and the ASOS or AWOS sensor is showing you a half-mile visibility. And as soon as that sun rises, the next report comes in at a quarter mile, and then we issue the blizzard warning. So this is kind of something to keep in the back of your heads. If you're forecasting in the middle of the night, and you're forecasting in the middle of the night, and you say, all right, I'm sitting at a half mile, it's kind of a way to get ahead of things, that that as soon as the daylight comes up and people start moving around, they're going to experience a quarter mile or less visibility. And maybe, if you expect those conditions to continue past sunrise, we can get that blizzard warning out a little bit sooner than just waiting until those reports come in from the ASOS/AWOSs at a quarter mile. So good news is we do have some guidance that can try to help us determine the impact level from a blowing snow event, which obviously would then help us to make more consistent blizzard warning decisions. This would be the Canadian blowing snow model, and I won't give too much of a backstory here. I don't want to go too long this morning, but Dave Bagley, very, very smart guy, works for Environment Canada. I went up there probably 12 years ago now, give or take a few years, I forget exactly, to one of their change of season workshops, and he was talking about this blowing snow guidance that he had developed, kind of a empirical algorithm that he had developed to try to determine how bad blowing snow events would be. He talked about all these factors that influence blowing snow potential. Obviously wind speed is probably one of the biggest factors, but something that we really had not realized yet is that temperature is also a big factor that can influence a blowing snow event, and as well as snow rate and as well as snow age. The guidance from this model is built into ForecastBuilder. So, ForecastBuilder uses this model in order to spit out the pot blowing snow grid. So the model is particularly sensitive, not only to wind, but also to temperature. So at colder temperatures, there's a higher likelihood for blowing snow given the same wind speed. And likewise, given a constant temperature, the stronger the winds, the more likely for blowing snow to occur. What this model tells us is the probability of visibility less than a half a mile. So, what is the probability that the visibility is going to be less than a half a mile within blowing snow? And, temperature and wind speed are probably the two biggest factors, but there's other things to consider, such as snowfall rate. Snow age is also important. So if you're talking about a ground type blizzard event, and the winds are going to pick up right after the snow falls, it's going to be require then less wind speed to obtain that half mile or less visibility, compared to if that wind was going to increase a day later, it would require higher winds to blow that snow around as the snow age increases. And then there's other things to consider too that are not built into this model, like is the snow blowable, or how much of the snow is blowable. And that's kind of one of the issues that we face in this current blizzard that's ongoing, is how much snow would fall, because right now we really don't have blowable snow on the ground. So, you know, those are things that are not built into this model that hopefully will be in the future. It's kind of built into the ForecastBuilder tool, which is great. You know, we've tried to add that in, but it's kind of not a perfect thing. I will also say that the Canadian blowing snow model assumes that you're in an open area. So at the current present time, it does not take into account sheltered area. So that is something in your mind that you need to adjust as well. So what we did is we kind of tried to then compare the blowing snow model output to the coverage from those blowing snow events that were in our database. And I apologize, this image turned out to be a little bit blurry, but I think you get the main point that you know, as the probability for half mile or less visibility increases from the blowing snow model output, the coverage of the half mile or less visibilities from the event also increases. So from the past blizzard events, there kind of is a correlation of increasing blowing snow model output to increasing coverage of you could say whiteout conditions, or at least observe half mile coverage. And you probably can't see this, but the R-squared value is 0.62. So we then kind of tried to answer the question. So we saw that it was a great correlation, and we wanted to then try to answer the question, does the correlation improve if we add duration into it? So, you know, remember before, what we kind of consider to be the two main factors that increase impacts from blowing snow events are duration and coverage. So what happened if we added duration into the calculation? So we made up this fake parameter. We called it the BSIL, or blowing snow impact level. And basically all we did is we multiplied the half mile coverage by the half mile duration and divided by 100 to, you know, come up with some made up value. But when we did that and compared it to the blowing snow output for each event, it did kind of increase that correlation, I guess you could say. The R-squared value you can see is 0.78 at least. So, you know, the way that I kind of look at this is, you know, the greater the BSIL, the greater the impact level from that blowing snow event. So as an aside, you know, I kind of why would that correlation increase if you added duration? And I have a couple thoughts about that. So the blowing snow model output is an instantaneous probability for visibility less than a half a mile due to blowing snow. So maybe this correlation is improving because longer duration blizzards, you know, typically have stronger winds and thus greater coverage. You know, that could be one explanation. Another kind of explanation is that the study was confined to using ASOS AWAS sites to calculate the coverage, right? So I think that the correlation of coverage to the model output might actually be higher. If we were to go back to this slide here, I would guess that if we had a true coverage and we were not just using ASOS AWAS sites, I think that this R-squared value would probably be slightly higher as well. So just kind of two brief explanations. So then, using kind of all that knowledge that we've gained up until this point, and looking at that blowing snow model output compared to the BSIL, I think we can say that increasing probabilities of the half-mile visibility from the Bagley model are associated with increasing impacts. And kind of from that tech attachment that Jeff published back in 2016, these probabilities are not perfect, but typically when the blowing snow model output is suggesting up to 60%, that's typically related with the low blowing snow impact. And as the blowing snow model probabilities increase, so do the impacts from the various blowing snow events. And I apologize, this table is opposite of the table I showed before, but hopefully you get the idea, and it kind of gives you an idea of how you can use a blowing snow model output to try to then message blowing snow events. So I want to go through a quick case study and then kind of finish up with some messaging. Should only be a 5 more minutes or so. But the blowing snow model output versus impact level duration, I think, is one thing that confuses our forecasters a lot of the time. And one of those questions and one of those discussion points that I think we really need to look further into and discuss further. So as an example, let's say we're in the very high impact level for 1 or 2 hours. Are the resultant impacts enough to issue a blizzard warning? And then what if you're in that moderate impact level for 3 hours, high for 1 or 2 hours, and the moderate for 3 hours? Are the resultant impacts enough to issue a blizzard warning? So just going back to what those impact levels mean, you're basically in and out 40–50% of the time. Whiteout conditions, it's not fun to drive in, but you can still get going. Then maybe for 1 or 2 hours, it's a situation where there's pretty widespread whiteout conditions, and travel is nearly or is impossible. But then you get back to that moderate level. Really those true blizzard conditions and that impact that we really want to probably try to wait for, that would shut down the world, is only lasting for 1 or 2 hours. But on either side of that, you have still serious conditions. Is that enough to issue a blizzard warning? So January 27th, 2019, we had snow, and you can see the snow that fell, along with southeast winds, 25 miles per hour, gusting to 35 or slightly over 35 miles per hour. Concentrate on, if I have my arrow here, concentrate on this area, kind of the northern Red River Valley, where we started out with a winter storm warning that eventually you can see becomes a blizzard warning. This image is just to kind of show you that, yes, conditions were very favorable for strong southeast winds as that snow was falling. And then obviously across central North Dakota, we had strong north-northwest winds that came down through that area, but we're not too worried about that area for this case study. And here's kind of the band of snow that fell across the Northern Valley, Grand Forks area, that occurred along with those winds of 25 gusting to just over 35. So imagine you're working and you're getting lots of reports like this. What are you going to do? It looks like a blizzard. Typically, we don't get blizzard conditions during southeast wind events, but the snow rates are pretty heavy, and it's occurring. We are gusting to over 35 miles an hour. It looks like a blizzard. So the next question that I try to get our forecasters then to answer is, what's the impact level? What are ASOS and AWOS visibilities reporting? And at this time, they were reporting 1/4 to 1/2 mile. And then the next question is, then how long do you expect that impact level to continue? And if you're expecting it to continue for another 2 or 3 hours, which our forecasters in this case were, is the reason why they went ahead and issued that blizzard warning. I'm not really here to answer if that was the right call or not, but that is the reason that was used. So this is just a meteogram. Actually, Andrew Moore, who's now at SPC, developed this for me from this event. This is just for the Grand Forks Airport. You can see this third row down is the visibility. The dash line is a half-mile visibility. And you can see that at periods of time we got below that half-mile visibility. And during this time where the wind gust ended up increasing to over 30 knots, to over 35 miles per hour, we were at a quarter mile for probably about 1.5 hours. And then, that was surrounded by, 3.5 hours of less than a half-mile visibility. So during this kind of 3.5-hour event, an hour and a half of it was actually sitting in that high category, where the other couple hours were sitting in the moderate category. So kind of the question that we asked after the event then, we expanded the blizzard warning eastward due to multiple reports of whiteout conditions within the falling snow, along with the strong southeast winds, and kind of that entire region, especially the Devil's Lake Basin into the Red River Valley, experienced that around 4 hours of at least moderate conditions. And within that 4 hours of moderate conditions, there were about 2 hours of the high conditions, or the high impact. Or another way to put it, constant whiteout conditions never occurred. Frequent whiteout conditions occurred for about 2 hours, or the high impact, and the occasional whiteout conditions occurred for another couple hours on either end of the frequent whiteout conditions. So the total blizzard was 4 hours, but the total constant blizzard was just about 2 hours. So that's kind of one of those marginal type events where I believe we're inconsistent from event to event, and it's a hard blizzard warning decision process. So poor Elmo there kind of needs a beer because he's getting stressed out and realizing that maybe trying to figure out whether or not to issue a blizzard warning is not the easiest thing in the world. What about another type of coverage? So this is an event we had a narrow band of snow that occurred in central Grand Forks County and then into western Marshall County in our forecast area. And what ended up happening is the winds increased very strong. Marshall County, Argyle, Stephen, Alvarado ended up canceling their schools for the day. It was perfectly fine and clear in Grand Forks. In fact, we had a forecaster that lived in Gilby at the time, and he tried to make it home after a midnight shift, and I think eventually made it home by about noon. He had to kind of sit behind a plow for a while just because the conditions were so bad. And I kind of wanted to throw this in there because this kind of screams for polygon type warning, because it was blizzard in this area. But another question to answer is, it's very widespread. Like the whiteout conditions were 100% constant in this area, but is the coverage of the total area enough to issue a blizzard warning? And in this case, we thought it was, just because of the impacts, just a very small blizzard warning. So getting into some of the tools, you're aware of the Forecast Builder tool that you have for blowing snow incorporates the blowing snow model. We are looking to make some changes for next winter season, which I'll mention quickly in a slide at the end. But if any office is interested, we do have a standalone tool that you can kind of run to the side to test out different outputs and to kind of see the raw probabilities that come out of that model. I think it's very important to see those raw probabilities when you're trying to make decisions. And it kind of also shows you the wind thresholds, which I love. It shows, if the blowing snow model is suggesting a low impact level, I think trying to see, and you're forecasting, say, 27 knots of wind, but there's a potential to have 30, 32 knots of wind. Seeing the probability, or seeing the wind thresholds that will get you to each blowing snow impact level, I think is important as we move forward to more of a modernized forecast process where we're trying to message alternate scenarios and such. I think that's an important thing to keep in mind. The other important thing to keep in mind with the blowing snow model is basically it's inputting deterministic values, right? So you're inputting just one set or one possible solution, and from our GFE grids, but yet we know that there's other alternate scenarios and there's other lower probability scenarios out there that we also need to account and message and keep in the back of our heads as we go through the forecast process. Along those lines, we also, another tool that we use is the sensitivity webpage that, again, Andrew Moore developed. Steve Flegel was nice enough to put it on his Aberdeen site within the CMS. But this tool has been very important for blizzard warning decisions. It allows you for real-time sensitivity testing. We know that the wind speed forecast is vital, and in this case, if we're forecasting 25 knots of wind along with half-inch of snow or half-inch per hour snowfall rates, this is telling us that there's a 60% chance that the visibility is going to be less than a half mile, which from our research have correlated that to that moderate impact blowing snow event. But this also tells us that if the wind increases to 30 knots, so let's say there's, we're pretty confident in 25, there's a 30 or 40% chance of 30 knots. This tells us then that it only requires, 5 more knot increase in wind speed that we're increasing the impact level of the blowing snow event. So this sensitivity webpage has been very, very vital for our operations, and it kind of allows forecasters to incorporate an ensemble approach to their forecast process. And I'll end up just with, I apologize, went a little longer than I thought here, but I'll quickly end with some kind of messaging thoughts. How can this information be used to message blowing snow and blizzard impacts prior to and during blizzards and blowing snow events? Hopefully, ideas are starting to turn in your head. We can look at, blowing snow impacts, blizzard severity. We can, message open country versus sheltered areas. I'm kind of thinking, hopefully the idea of impact-based type messaging has entered your head as we've gone through this presentation. And the other thing we have to keep in mind that we probably don't do enough of is, what do our customers think? How do our partners react to our decision making and messaging? And what do our partners consider, or how do our partners answer the question of what is a blizzard? And we've done that some of that in the past, and the feedback that we've gotten is majority of our partners consider a blizzard to be those top two, those very high and high impact level, and that moderate impact level to them really is not something we want to shut down the world. That's not, unless you're adding other factors into like drifting or whatnot. And we have to also try to get into probabilistic blizzard messaging as well. What are the chances for a blizzard to develop? If you have a winter weather advisory out for blowing snow, our partners have told us that they want to know what is the chance that is eventually going to be upgraded to blizzard warning, because that is something that often happens. And then the last one, Andrew Moore gave a great science sharing presentation on the blizzard severity index that he continues to develop. And I think the next slide kind of talks about that just a little bit. So this is an actual BSI score for, I believe, our forecast area. And basically what this attempts to do is utilize climatology to determine blizzard severity. The blizzard snow model is a component of this calculation. We have to keep in mind that even with consistent whiteout conditions, that's going to be a blizzard. You may be in that very high blowing snow impact level that we've just talked about, but there's other factors that are going to then increase the severity of that blizzard, or basically increase the recovery time of that blizzard. So you could have a ground blizzard event that has constant whiteout conditions, but as soon as the winds die down, people are out traveling and going about their business. But if, let's say, you have that same type of constant whiteout condition event, but then you add a foot of snow in there, or wind chills are -50, that's likely going to increase the recovery time from that blowing snow event or increase the blizzard severity level. So this is still kind of new for our in our operations, but it's my hope that it kind of can ensure better event-to-event messaging consistency. And it came about because of an event that we had messaged as historic that really wasn't historic. It was historic where it occurred, but the coverage of those very large or of that very high severity was pretty limited, and the recovery time was pretty long where that occurred, but like I said, the coverage is pretty limited. And if you're talking historic, you probably want the coverage of those severe conditions to be fairly widespread, and you want the duration to be fairly long as well. So currently this is only point only, and we still need to really figure out a way to also build in duration and coverage. This is another idea that Bismarck is trying this year that hopefully we eventually get some templates for, that basically uses the pot blowing snow grid and messages the impacts and messages where you may expect a near blizzard or blizzard, and then also then separates into the blowing snow and just kind of the patchy blowing snow. So kind of going along those impact levels, low, moderate, and then high and very high would be the near blizzard or blizzard category. These are some forecast builder updates that we're planning for next season that I just kind of wanted to quickly mention. The two biggest ones would be these bottom two check marks that I'm at least most excited for. Building in a sheltered area, edit area, where the offices can determine, if they have larger cities or if they have forested areas that it's very hard to get blizzard conditions for. It's these sheltered areas where it requires snowfall rates of greater than a ½ inch per hour, and most of the time requires snowfall rates closer to an inch per hour to really see constant or true blizzard conditions. So, putting in these sheltered edit areas, I think is going to help with these with those sheltered areas and the blowing snow output that oftentimes for these areas is a little bit overdone. And then, the other thing that the blowing snow model doesn't currently account for are snowfall rates greater than a ½ inch per hour. So what we're planning on doing is basically assuming that the quarter-mile visibility, assume that you have a quarter-mile visibility when the snowfall rate equals an inch per hour. And then if that visibility equals a quarter mile due to the snow rate with winds greater than 35 miles per hour or wind gusts greater than 35 miles per hour, then the model output will get up to 100%. And then for any snowfall rate between a ½ inch and an inch per hour, just basically interpolate from that ½ inch per hour model output to the inch per hour model output. It's not perfect, but I think it's kind of that first step toward improving the model, especially for those higher snowfall rates. And then the last thing that I will mention, and unfortunately we're not able to get the blowing snow probabilities or the pot blowing snow into NVM 4.0. We were a little late in that process, but we have given our documentation and our ideas to the NVM developers. So hopefully in NVM 5.0, there will be blowing snow output. The two main things that I'd be looking for that I hope do get into NVM 5.0 would be the blowing snow probability, basically, which would tell forecasters at each hour or instantaneous point the probability of the visibility being reduced to a ½ mile or less from blowing snow. There'd have to be some training, obviously, how that relates to impact levels and such, and how to use it. But I think that's pretty comparable to our current pot blowing snow grid. And the one thing that I'd be really excited about, and after talking with David Bagley a little bit on how to do this, is trying to determine the blowing snow blizzard probability. So what's the probability for blizzard conditions to develop? Kind of using or going along the same lines same thinking as how the precipitation type probabilities are currently being calculated. And for each hour, if a blizzard is yes, or basically, you say a blizzard equals yes if the half-mile output is greater than or equal to 80% for the previous 3 hours, and obviously get the wind gust criteria being met as well, and then figure out the percentage, and that would be for each member, and then figure out the percentage of the NBM members where blizzard equals yes. And I think that is probably, I'm excited for that if that ever comes to fruition. And, you could do the same thing calculating near blizzard probabilities using an output probability of 50%. So looks like I talked for an hour, which is crazy for me, but I guess I had a lot to talk about. So thank you. Thank you for your time, and I'll throw it out for any questions or anything else anybody would like to add or comment on.